What if the universe is not the eternal, unshakable canvas we imagine when we stare into the star-washed darkness of night? What if beneath that serene cosmic glow lies a ticking clock, a silent countdown encoded into the very fabric of space-time? We think of galaxies as permanent, stars as everlasting, and atoms as the basic, unbreakable units of reality. But the deeper we look into the cosmos, the deeper we look into physics, entropy, dark energy, and the fragile architecture of existence, the clearer it becomes that nothing lasts forever. Not stars, not galaxies, not even protons, not even the universe itself. Every cosmic sunset has a final nightfall. Every beginning echoes its inevitable end. And so the question becomes, how does the story of everything actually end? Will the universe freeze, collapse, or violently tear itself apart? To answer that, we must embark on a journey across unfathomable epochs, trillions upon trillions of years, far beyond the lifespan of stars, beyond the evaporation of black holes, beyond the dissolving of matter itself, until consciousness, chemistry, light, and structure all fade into an almost mythic memory. The story of the universe's death is not simply scientific. It's poetic, terrifying, beautiful, and vast beyond human imagination. From our tiny world, orbiting a modest star on the edge of a spiral galaxy, we try to grasp the birth and fate of a cosmos stretching 93 billion light-years across. A cosmos filled with superclusters, voids, quasars, and dark matter filaments stretched like invisible nerves through an unimaginable cosmic brain. But to understand its end, we must begin at the beginning. 13.8 billion years ago, everything, the laws of physics, the seeds of galaxies, the energy that would one day ignite the stars, burst into existence from a single blazing moment we call the Big Bang. Quantum fluctuations inflated into megaparsecs. Gravity sculpted primordial chaos into structure. Hydrogen clouds collapsed into stars. Stars forged heavier elements. Supernovae scattered those elements into space. Planets formed. And on at least one, life arose, evolved, and gained the ability to reflect on its own origins. But all of this, all of existence, is temporary. No star burns forever. No galaxy endures eternity. The cosmic web itself is fragile, stretched across an expanding space-time that grows thinner and colder with every passing second. To truly imagine the universe's death, we must fast forward across incomprehensible spans of time. What happens in a billion years? A trillion trillion. Humans struggle to visualize centuries, yet the universe's fate unfolds across a calendar so vast it dwarfs all meaning of future. So let's travel through cosmic time and witness the final destiny of everything. In the next 100 trillion years, the stars will begin to die. Star formation will cease as galaxies exhaust their reservoirs of hydrogen gas. Red dwarfs, the most common and longest-lived stars, will burn their final traces of fuel and dim into cold, dark spheres known as black dwarfs. The night skies of distant civilizations, if any survive that long, will gradually empty. The once dazzling spiral arms of galaxies will dissolve into skeletal halos of dead stars. Gravity will continue its endless work. Large galaxies like the Milky Way will merge with neighbors, eventually forming massive elliptical galaxies made mostly of dead stellar remnants. Black holes at galactic centers will grow more enormous as they swallow stars, gas, and even other black holes. But even they are not immortal. In a Google years, 10-100, black holes themselves will begin to evaporate through Hawking radiation, dissolving into bursts of energy before disappearing entirely from existence. After the last black hole evaporates, the universe enters its most desolate phase, the dark era. No stars, No planets, no atoms, only sparse, stray particles drifting across expanding nothingness, separated by distances so vast that crossing them would take longer than the age of the universe repeated a trillion times. This is the Big Freeze. Cold, silent, eternal expansion. Entropy maximized, temperature approaching absolute zero, information spread thin across an infinite void. A universe where nothing happens because nothing can happen. But this is only one possibility. Another possibility, though less likely with current data, is the Big Crunch. In this scenario, dark energy weakens over time. Gravity slows the expansion, halts it, and eventually reverses it. Galaxies converge. The night sky fills with fire as stars collide. The cosmic web collapses inward. Temperatures climb to unimaginable levels. Every atom is ripped apart. And at the final moment, everything collapses into a singular point, a cosmic rebirth seed, perhaps triggering a new Big Bang, meaning the universe is a heartbeat in an endless cosmic cycle. The final possibility, and perhaps the most terrifying, is the Big Rip. If dark energy grows stronger with time, if it becomes phantom energy, its repulsive force will eventually overwhelm all structures in the cosmos. First, galaxy clusters are torn apart. Then galaxies themselves unravel. Stars drift away from their orbits. Planets detach from stars. The expansion accelerates beyond all control. In the last minutes, atoms themselves are stretched until molecular bonds break. In the final milliseconds, nuclei are ripped apart, and at the last instant, even space-time fractures as the universe tears itself into oblivion. No cold eternity, no rebirth, no remnants. Pure annihilation. But which fate awaits us? Observations suggest the Big Freeze is most probable. Yet dark energy remains the greatest mystery in physics, meaning the future is still unwritten. But here is the extraordinary truth. We are the first known species capable of predicting the fate of the universe. A species that evolved on a tiny rocky world in a small solar system in a nondescript galaxy, now daring to calculate the timeline of cosmic eternity. We glance up at the stars and see constellations. But what we're really looking at are temporary flames, sparks in a cosmic night that will one day go completely dark. We dream of traveling to other worlds, yet those worlds also live inside a universe with a finite lifespan. Every star, every nebula, every quasar is a brief flare in a grand cosmic firework that eventually fades. And yet, knowing this does not diminish the universe's beauty. On the contrary, it makes everything infinitely more precious. The stars shine brighter when we understand they will not shine forever. Our brief moment of consciousness becomes extraordinary when placed against the backdrop of cosmic impermanence. Our existence is a flicker in a 100 trillion year night, but within that flicker we can comprehend the death of galaxies, the fate of matter, and the final breath of the universe itself. And perhaps, in that awareness, we transcend our smallness. Because the universe will end one day, but the fact that we can tell its story makes us part of something larger than stars, larger than galaxies, larger than time itself. Maybe consciousness is how the universe learns about its own impermanence. Maybe life is the cosmos becoming aware of its fate. Or maybe we are simply witnesses to a grand cosmic drama whose ending is inevitable yet profoundly meaningful. The universe will freeze, collapse, or tear apart. But in this moment, right now, the universe is alive with light, structure, chemistry, gravity, and the miracle of beings who can wonder about all of it. And so when you look at the night sky, when you see the ribbon of the Milky Way stretching across darkness, remember, those stars are temporary, but the questions you ask about them echo across eternity. The universe will die one day, but the human desire to understand it is timeless.